Welcome everyone to part 8 of the ESTeem wireless training series, where we're going through all aspects of the operation of our wireless products. In the earlier sessions, we cover everything from the basics of radio. We've gone so far into highlighted a lot of the features and characteristics of the radio series that we have in total. We've concentrated on the wireless Ethernet radios and how we interface those into multiple modes of operation, from bridges, routers, firewalls, mobile clients, everything that's necessary for it. So once we're now into part 8 of this series, we're going to take a look at how we work with some of our legacy hardware. All of our radios that we manufacture, covering all the different frequency bands, you'll notice that every one of those has both an Ethernet interface, usually for modern communications equipment, modern PLCs, RTUs, everything that has to do with industrial control, and the world as a whole really has gone to Ethernet as a model. But there are a tremendous amount of devices that are still using serial communications, and you'll see serial listed by how it's electrically done, from RS-232, RS-422, RS-485. All of these are serial type interfaces. They're generally slower than you'll find on an Ethernet interface, but they've basically been the workhorse in the industrial communications world for 30, 40 years now. And a lot of hardware still has a serial interface on it. Because of that, we've kept that in our radios, and every one of our radios has a RS-232 data interface on it for that very reason. A lot of cases, especially the higher speed radio series, we've kept that on there for a very, very specific reason, and the fact that we can actually run what we call serial over broadband. Really what we're doing is we're taking the serial information that comes in from the connected device. We're actually using that Ethernet framework and making that serial data inside of an Ethernet packet. Well, these Ethernet packets are a little bit different than what other Ethernet devices are going to be looking for. So it's really what it is a customized Ethernet packet that only our radio systems will recognize and do something with. The Ethernet information, the serial information that is put out by the PLC or the RTU, that's actually injected inside of our Ethernet packet is what's called the payload. That's the data itself inside of the packet. Now, the reason that we kind of lump all these together and call it serial over broadband is we actually have 4 different radio series. We have the Horizon series, which is our highest speed, latest interface. We have the Edge series, which is a lower speed 900 hopper. We have a 210 series, which is the high speed Ethernet over licensed channels in the 150 to 174, the 450 to 470. And then we also have one other series, which is our narrowband series. The narrowband series handles serial communications. I guess the best way to characterize it is natively. It handles serial packets as serial. All of our other products, everything from the Horizon series to the Horizon series, Edge, the 210, all of them handle it the same way, in that it is actually a serial data inside of an Ethernet packet. Why this is important to understand is that when we're talking about a serial communications between devices, really what you're doing is you're going to configure it exactly like an Ethernet interface. There's no changes to it. You lay the networking out exactly the same way. It works in all modes. It'll work in bridge mode, router mode, firewall mode. Any of the modes, this RS-232 data port actually functions the same way. And all your troubleshooting and diagnostics is going to be exactly the same. So even if you have a strictly serial network running on the Horizon Edge and 210 series, you're going to do all your troubleshooting as if it were a wireless LAN network. There are no changes to it. So it makes it very simple that way. The serial links on any one of those types are what we'll call transparent. In other words, the the radio itself does no emulation of the protocol. It does not look into the protocol of the radio to find out what's actually happening within that data source, to see where it needs to transmit it to, or to use it as a repeater, anything like that that we used on a lot of our older series of radios. So the transparent mode, effectively most of the most of the serial industrial protocols out there work just fine over transparent link, whether we're talking about Modbus protocol or Opto22 or DNP3. The only one that cannot be run over this transparent type of communication is one of the Rockwell protocols, one of the Rockwell serial protocols, which is known as DF1. There are actually 3 different modes of DF1 because of how it came out into the world. There's what's called half duplex, full duplex, and radio modem protocol. Full duplex protocol is the only one that cannot support a transparent communication link. So just about every communication protocol in the world except for DF1 full duplex will run just fine over this serial over broadband type communication. There really are 2 main modes of operation when we're talking about serial. And it's very simple that either the communication that comes, the serial communication that comes into one radio gets sent to one specific site, or everybody gets it. So either we're going to do a point-to-point link, or we're going to do a multicast. So the way that this works in most cases is if you run it in kind of a hub and spoke type configuration, your master will send communication out to everyone, and then the remotes will reply. They'll be set in kind of a point-to-point back to the master. If you have all the sites need to hear all of the data, then all of them can actually be done into a multicast format. The beautiful part of that is the Ethernet back end, or the Ethernet communication link that's established prior to this. It actually handles the multicast traffic so that you do not need to identify which sites in the network are repeaters, anything like this. All devices within the network will actually receive it if put out into a multicast packet. So what does this actually look like? Which ports are we talking about here? Well, let's go ahead and review the Horizon once more time. What we're talking about here, the Horizon actually has 4 communications ports on the front of it. There are actually 2 Ethernet ports, which I'll mark here first with checkboxes. There is the RS-232 configuration port, which we had talked about in detail on the previous section when we were in the advanced. The one we're making reference to now is this one listed as the RS-232 data port. Now it looks like an Ethernet port because it has the same physical type connection, but electrically the lines inside of that port are RS-232. We keep it as an RJ45 connector, quite honestly, for the size on the interface of it. To put like a 9-pin port or a 25-pin port or any other type of serial common port that you'd see there just takes up too much real estate. So if there is a standard 9-pin connector you're going to, we actually manufacture, we have a cable that goes from this RJ45 connector that you see here on the front of this data port, this one here, and it then converts into a 9-pin port that looks like the 9-pin serial port on the back of a computer. So we do have that, that adapter if necessary. When we're talking about, say, the Edge 900 radio, the Edge 900 is pretty simple. There's actually only 2 ports, one of them being the Ethernet port and the second one being the RS-232 data port. So again, the same way, it is electrically RS-232, although it's physically in that RJ45 format. So we have the adapter to it, or you can wire it up. All the port layout, it's very simple. You can just put an RJ45 and then a 9-pin or 25-pin port on the other side, and run your own cable to it. We have that, all of that information inside of the user's manual. The 210, which is a little bit older radio than the Horizon and the Edge series, that one actually is physically larger. It's not set up to run in an outdoor configuration. Because of that, we actually can have a physically larger case on the radio. And as you can see here, this has a standard 9-pin RS-232 data port. It functions the same way in the way that it transfers the information. In other words, it takes it in and transfers it over the Ethernet network that is established. but that one has a different, just a physical port into it. It's really the only major difference between it. Now, as I mentioned earlier, there are really a very few configuration parameters that need to be set to get this serial data port to work. It's all done actually on a single configuration page. You're just going to set the data rate, parity, stop bit, what the transmission character, so that the radio knows what is essentially the end point of the data format coming into it. And finally, we need to establish what format the data is coming in, what speed, what parity, start, stop bits, things like this. Everything that you would normally configure when configuring an RS-232 port. In a multi-point system, essentially all remotes will receive the data. It just is set as a multicast address. The multicast address that we use by default will actually push through any router, anything, any routers, firewalls to it. You can use a different type of multicast address, but the one that we have will push through just about everything. We actually can separate different networks within a single port, within a single wireless system by its port number. So before we get too far off of that, let's go ahead and jump over to the radio and take a look at how we actually configure this. So what I'm going to be plugging into, this is actually the main page off of our Horizon series radio. This is actually the Horizon 900 radio, as you see listed right here. All of them, as far as serial communication, work effectively the same way. You'll see listed down here below where it says RS-232 port status. Oops, grabbed the wrong one. RS-232 port status down here. What this is telling us is that the device is not active. So we really, by default, only turn on the serial port when it's going to be used. So to activate the port, it's very simple. We simply go over here, press the advanced button. Down the very last item that you'll see listed under port settings, it says RS-232. We select that and hit next. And what this is going to do is this is going to bring up the RS-232 data port configuration page. And as you can see here, it is just a single page. There are a few items on here that need to be filled out. Once this is done, then you can actually hook up an RS-232 device to it. And the beautiful part is that the RS-232 packets, from the time that it takes to process those is so much slower than it normally takes to process Ethernet. You can really run serial over it at almost as fast as it'll possibly go, and it has very little impact on the overall throughput of the system. It's RS-232 really has very little effect on the overall bandwidth of the system itself. There's not much to be concerned with. So the first thing you can do is, as you notice here, the serial data port by default is turned off. If we want to turn it on, it's just as simply you change it from off to on. Then you set the serial data baud rate. The baud rate is going to be matched up to the connected device. So if your connected device is running at 38,400 bits per second, then you set it at 38,400. Same thing when we're talking about data bits being either 7 or 8, stop bits and start bits being 1 or 2, and whether or not the parity, whether it being even, odd, or none. Again, not going into a whole class on the way that serial works, the easiest way to look at the way to consider this is you're going to match up the radio's configuration to the serial device. Each one of those parameters is all part of the serial communication. So it's just a matter of matching those two up. The next one is flow control. The radio actually supports both hardware and software flow control. So there is a request to send and clear to send line in that RJ45 connector. We have both transmit, receive, ground, RTS, and CTS is also in there, so we can support flow control, hardware flow control. Software flow control is actually controlled by characters inside of the data stream, and we can do that also. By default, it is set to off. Now, when we get into the configuration side of it, there are really only a couple things that we need to look at. The first thing is when we're talking about the number of hops, in other words, we list it as maximum bridge hops. The reason that we want to put this in here is in most cases, the transmission of serial will go beyond just one single remote. In other words, what you see listed below here, this 224001, is a multicast address. That's what's put into the radio by default. If it goes in there, every radio that has a serial port turned on will receive it and pass it out the serial port. Because of that, essentially that multicast address will pass around all of the devices inside of the network and then start switching and going inside of the network to where it could go through a router, go through a firewall, things like this. So we want to be able to effectively get it to go within the wireless system. As soon as it gets to the wireless system and to our radios, we want it to effectively stop. We don't want it to keep hopping indefinitely. So because of that, we have this maximum bridge hops that we put in there. The easiest way to do this is just count the number of ports, Ethernet ports, to get to a destination. Let's go ahead and take, for example, let's say we've got a point-to-point system that we're putting in here. Well, in a point-to-point system, the maximum number of bridge hops, we have one port on one side and one port on the other side. So that would be a maximum bridge hops of 2. If we're going to use a repeater in between there, so we go from the source radio to a repeater to the destination, then there are 3 ports in there. So we would change this max bridge hops from 2 to 3. So it's just that simple. So you just look at how many radio chains do we need to get to finally end up to where it is. So if there's 2 repeaters in the system, then the max bridge hops would be 4. So the only thing it would do is if you set the number too low, it effectively will cut it off before it gets to the final destination. All right. If it's going to a single address, in other words, if we put in here, as you see here, there's a big block here for destination IPs. The reason it's written this way, and a good thing to kind of point out now, if you've got any questions on where this comes from, anytime that you put show info, what it will actually do is that it will bring up the help component of each one of these. We have this almost on every page within our radio. We also have it in just about every item within the advanced menu. So for example, if we look at the destination IPs, you can put in a single IP address, or if you've got 2 radios that you want it to go to, you can put in one IP address followed by a second IP address. If you wanted to go to a block of IP addresses, say from 172.16.3 all the way to 172.16.14, you can put them side by side. So if we started out and it's 172.16 1.1 to 172.16.14, it'll cover all addresses from 1 to 4. So it is a very simple way of putting in multiple destinations or a block of destinations. If you want it to go to everyone, then you can just leave it at this default. The only thing that's listed here is that if you are doing a multicast address, then like a 224.0.0.1, which is a multicast address, if you're using that, only one address will be allowed in this block, or it will actually throw an error. Once that's done, we've established how far or how many hops do we have within the system. Binding it to an IP, by default, you can actually bind this to a specific IP address within the radio. If it is changing, going to different IP addresses, or it is in a DHCP client mode, something like this, you can always lock it to 1 so it'll never change. By default, it's set at 000, and that means it binds to essentially all IP addresses. It isn't locked to any particular one. The key to this, though, is once we've established either it's going to all points or a single or multiple nodes, what allows it to pass out of the radio at the opposite end, at the remote end, is it has to match this destination port number. So it's not only an IP, it's an IP and a port number. So effectively think of this as the number that sets the network address, so that every device that is going to receive the same serial communication, or is going to be in a serial communication network, has to have the same destination port number. Why this is important, and the reason that we put this in there, is if you've got a large complex wireless network and you have multiple serial networks or multiple devices that want to use that wireless network, we don't necessarily have to have them all share the same serial data. We could have 5 devices on one side of the plant using one destination port number and 5 devices on the other side of the plant that are all talking to each other, it could just use a secondary port number. And that port number can be anything. So by default, it's set at 1412. If we wanted to set up the second one, we could set up the second one to say 1413. It doesn't really matter at that point, just as long as you keep in mind that the destination port number has to be the same for all of the radios that are going to share serial communications. The last ones here actually just are some parameters on how we tell the radio to recognize what is the end of the data block or the serial data block. Because the key to this is having the radio say, okay, I know this is a complete serial packet. I'm going to then take that, turn it into an Ethernet packet and send it to the other side. So how does the radio recognize it? Well, we can do it based upon packet size. So if the serial packet coming into the radio is always 100 bytes, you could set the maximum packet size at 100 bytes. So as soon as the radio receives 100 bytes of data coming in from the serial port, it says that's the end, turns it into a serial, one serial block, sends it across to the network. If that is unknown, then you can always just leave this at the maximum packet size at 1024. And then we can either do it based upon one of two things, either a time or what's called a delimiter, a specific ASCII character. So there are a lot of protocols, say for example, Modbus still uses an older type to where the end character in Modbus always ends into what's called a carriage return. And so you could actually set the delimiter to the, for this particular, if it was using specifically Modbus RTU, then you could always set your delimiter character to one device or one thing. So it would be, I believe it's a 13 is the hex character for it. I do apologize, I don't have my cheat sheet in front of me. But really what this is this is the hex character of the ASCII equivalent for it. But in a lot of cases, that will never change. In other words, a lot of serial type protocols, they generally will end with an error check on them or a cyclic redundancy or CRC check. And really what that means is the end character will always be the same and the size of the packet may be different. So in those cases, and that's why we by default generally set everything at what's called a dwell time. And really what that is that means that the radio itself will look at the data coming into it. After it receives its last byte of data coming into it, it waits this amount of time that you see listed here. And as we see, we open this up, that's a matter of milliseconds is what that is. So what it'll do is it'll wait 10 milliseconds after the last character and says, oh, I'm not going to receive any more. That must be the end, and sends it across. On a slower speed network to where we're, say, running this at, say, 2400 baud, well, 10 milliseconds may be too fast. So you may actually set that to, say, 100 milliseconds. You can customize the configuration to however it works best for the serial application going into it. Now, we see here that this is a very, very simple on and off process. And once we've set this to make it turn on, in effect, we just simply hit accept the parameters and then we commit and reboot it. So when it comes back up, it'll come back on here, it'll have RS-232 port settings, and it'll give you port is active, and it'll give you the parameters that it's set to. 19200, no parity, 8-bit stop, one stop bit. If you see anything listed in here besides device not active, the serial port is active on the radio. Again, it's not going to do anything unless it receives serial data coming into it, so there really is no detriment to having it on. It's just, quite honestly, no reason to leave it active if there's nothing plugged into it. So the last thing that we're going to take a look at is overall, how does this work? Well, keep in mind what we're doing is we're actually creating what's best to characterize as a hybrid network. In other words, the system itself can handle both Ethernet traffic and serial traffic at the same time. They can actually work simultaneously to it. The beautiful part of that is that gives us the ability to use a wireless network, any one of our wireless radios. If you've got all old serial-based hardware, you don't need to replace all of the controllers in the network at the same time. This will give you time to start changing or updating the remote systems to Ethernet, and both of them can run at the same time. It also gives the ability to have a serial network and say a video link out at the remote that would be running on Ethernet. So there are many different possibilities of what can do this. And as I mentioned earlier, the biggest part is the serial network, no matter how hard or how fast it's set up, has very little impact on the bandwidth, because quite honestly, most of these radios are so much faster than serial communication can go into. So hopefully that was informative. If you've got a serial network, you've got any questions on how to do this, how to lay the network out, we'll of course be happy to do that. You're always welcome to give us a call, send us an email to support@esteem.com, kind of give us an idea of what you're running into, what your network wants to be. We can do very many different types and complex networks with this if necessary. I want to thank you for your time today, and we will talk to you again soon.